Hi, it's Professor Jones again. Let's take a look at a few more problems from section 2.2. Here we see um, number 38 from section 2.2, where we're given a piecewise function. So this is a function which is defined using a variety of functions, and they're used to form a single function. So in this case, if x is less than 0, um, the function equals 6x minus 1, and if x is greater than or equal to 0, the function equals 7x plus 3. So we're asked to find f of negative 3. Well, that essentially means that since negative 3 is less than 0, then I'm using 6x minus 1 to calculate this. So I replace x with 6 times, I replace x with negative 3. So I obtain 6 times negative 3 minus 1, which is negative 18 minus 1, which is negative 19. So f of negative 3 equals negative 19. Now, f of 0 is a value calculated of the function where x equals 0. And we see that 7x plus 3 is what we use when our x is 0 or anything bigger. So 7 times 0 plus 3. We replace the x and 7x plus 3 with 0. So we see this is 3. So f of 0 is 3. F of 4, since 4 is bigger than 0, we use 7x plus 3, replacing x with 4. And we see that we obtain 31. So f of 4 equals 31. All right, so that's how we would work that problem. So which portion of the function's definition I use depends upon the value of x and the descriptions that are given for x in the function's definition. So let's look at number 54. Here I'm being asked to graph the function. And so I want to use the graph to determine the function's range. So notice if x is less than negative 3, the function's value is 0. So that means I'm going to have, for all values of x less than negative 3, I'm going to have a y value of 0, which would be the negative x-axis for all x less than or equal to negative 3. So what we'll want to do is we want to show clearly where that is. And notice this is the value of x if x is less than negative 3. So I'm moving to the left. So I have an open circle at x equal negative 3. And then I have this portion shaded to the left. And since f of x equals 0, my y is 0, notice that that means I'm on the x-axis for all x's that are smaller than -3. Now, I use f of x equal -x if x is between -3 and 0, including -3. So whenever these endpoints are given for these intervals that tell me where to switch to another function, I have to find the value of the function at the endpoints. So f of -3 will be -3, which is 3. So when x is -3, the value of my function is 3. Alright, now this is going to be an open circle. A closed circle. It would be right above x equal to 3. And this is closed above -3 because x greater than or equal to -3 uses the function -x. And now we see that if we replace this with 0, so notice we also need to find the value of this endpoint. -0 is 0. So, but x is less than 0 when we use -x. So that means we're going to have an open circle at the point where x is 0 and y is 0, because -x is 0 if x is 0. So I have an open circle there, and I connect these two dots with a line. So I get this line segment when x is between -3 and 0, including -3. Now let's do f of x for x greater than or equal to 0. Well, f of 0 is 0 squared minus 1, which is -1. And then I just need to plot I need to plot a solid circle at -1 for this. The reason being, so when x is 0, y is -1. And so notice, I know this, and so if I wanted to, I know this is a parabola, and when x is 0, I'm actually at the vertex of the parabola. And so I just need to calculate one more value of the function that's bigger than 0. So here I calculated f of 0, and I need to use a value that's bigger than 0. Let's try 1, x equal to 1. So f of 1 is 1 squared minus 1, which is 1 minus 1, which is 0. So I know this is a parabola, And this, plotting this other point, is just going to help me. So I move 1 unit right of the origin, since x is 1, and I plot the point 1, 0. And so the function would look like this. Alright, so that's the graph of our function. Let's look at the next problem, where we have a cell phone company offering the following plans, Plan A and Plan B, and we see that the plans utilize functions that are piecewise function. So the first function costs $30 per month, and it buys the first plan, Plan A, $30 per month buys 120 minutes. So each additional time costs 30 cents per minute. So in other words, if your time lies between 0 and 120 minutes, including 0 and 120, then you pay $30 each month. So over the month, you use anywhere between 0 and 120 minutes, you would only pay $30. As soon as you start using more than 120 minutes, so if t is bigger than 120, then your cost is calculated using this expression, 30 plus 0.30 times t minus 120. And I have something kind of similar for the Plan B, except it's more expensive, but you get more minutes. So $40 per month buys 200 minutes, and each additional time costs 30 cents per minute. So there's that function. So simplify the algebraic expression in the second line of the piecewise function for Plan B. Then use point plotting to graph the function. So that actually is 40 plus 0.30, we're using the distributive property here, t, minus 60. So this is equal to 0.30t minus 20. 40 plus a negative 60 is minus 20. So anytime my time value is over 200, then I'm going to be paying this monthly payment. 0.30 times the number of minutes I used minus 20. So in order to graph this, I realize that the function is constant between 0 and 100. And that's actually where the function starts, between 0 and 100. So here's my function. Starts at 0 is what I meant to say. Okay, so let's actually just bring that over from the other page. So put in this simplified version of the second portion of this Plan B function. So when we're between 0 and 200, the function has a value of 40. So let's say this is 40 right here. So this is constant between 0 and 200. And let's let's say this is 200. So we'll write our 40 here. We'll say right here we're at 200 with our t value. And so one of the things we need to calculate is we need to calculate the value of 0.30 times 200 minus 20. So that's equal to 60 minus 20, which is 40. So this new function connects right with the old function right here. Both functions actually have a value of 40 when t is 200. If they didn't, if the values were different, we would have a gap or a jump here. All right, so then we know that at 200, our new function that we're using for values of t that are bigger than 200 starts right here. So there's no discontinuity, no jump or gap. And now let's find what the value of this is. Oh, let's maybe put in 300. For t. So we're replacing t with 300. We just need any single value of t that's bigger than 200. So 0.30 times 300 is 90 minus 20 is 70. So 70 would maybe be somewhere right about here. And I just I could have used any value bigger than 200. And so when I'm at 300, so this would be about 100 here. And so 300 would maybe be about here, just doing it kind of roughly. And when I'm at 300, I'm at this value of 70. And so I want to draw a line that connects me from this portion to here. And that line actually continues indefinitely. So that's what the function would look like. Something along this line. And notice how I use point plotting to obtain this. Alright, so that's all we were being asked to do in number 80. Here in 82 we have an application problem. We want to write a piecewise function that models each cell phone billing plan. So let's follow suit from the previous problem, and let's call this C of t. And we're told that $60 a month buys 450 minutes. Additional time costs 35 cents per minute. Alright, so that basically means the cost is $60 if t is between 0 and 450. if um, t is more than 450, I still have to pay the $60, but now I have to add to that this 35 cents times the additional minutes. So that would be, so remember my t's here are going to be greater than 450. So that would be t minus 450. And a lot of times when you're doing something like this, if you're not sure if you have it right, test it. So if I use 451 minutes, that would be the $60 plus 35 times 1. Well, how do I get this quantity to become 1? I would subtract 451 minus 450. And so if you're a little unsure if you've gotten this right, then just try a few values to see if what you've written actually makes sense. So if t is between 0 and 450 inclusively, the plan cost me $60. So the amount of minutes you use each month is between 0 and 450, including 0 and 450, then you pay $60. If the amount of minutes you use each month are greater than 450, then you pay $60 plus 35 cents times t minus 50. All right, and that would be my function.